The next example, we're going to do G. Now, I've been sort of meandering and going about this slowly. The process that I'm going to stick with is I'm going to find my lowest common denominator. And then I'm going to multiply by my lowest common denominator. Now, if you want to create a common denominator, then cross them out. That's your business. But this is, I'm going to choose one method and stick with it. So now, this is where restrictions sort of come into play, I'm going to suggest. So restrictions are basically where our denominator is equal to 0. Well, x minus 3 cannot be equal to 0. And x minus 2 cannot be equal to 0. My denominators can't be equal to 0. From the first one, I get x cannot be equal to negative 3. That's the x value that makes the denominator 0. So x can't be equal to positive 3. And for that second restriction, x minus 2 can't be equal to 0. Well, that happens when x is equal to 2. So x can't be equal to 2. There we are. Now I look at my lowest common denominator. My lowest common denominator is actually this factor. Well, it has to include the factor x minus 3. And it also has to include the factor x minus 2. Those are distinct factors. So totally different factors. So now, I know some of you guys are probably panicking just a bit, but this is going to get kind of fun very quickly. So I'm just going to write down my question, if you don't mind. There it is. All of these basically start off the same. I identify my lowest common denominator. Well, it's x minus 3, x minus 2. So I'm actually going to multiply both sides by x minus 3 and then x minus 2. Now, both sides are consisting of one term, so that's really good. Makes it easy. Now, this looks crazy. We have a whole bunch of factors of x being multiplied, and it doesn't look good. But now, take a look. We have a factor of x minus 3 that cancel each other out. And on the right-hand side, we have a factor of x minus 2 that cancel each other out. So really, what I'm left with is x minus 2 times x plus 2, and this is equal to x minus 1, x minus 3. Wouldn't you know it? We have a quadratic equation. Everybody loves those. So I'm just going to simply multiply it. The left-hand side, I notice, is conjugates. So it's x squared minus 4. The right-hand side, I'm going to have to multiply, right, through. And what I get is x squared minus 3x minus x plus 3. I'm going to try to clean this up ever so slightly. I hope you don't mind. This is turning into a terrible, terrible mess all of a sudden. But that's quadratics. So I'm going to bring everything over to one side, use the zero product property. So I'm going to bring the left-hand side over there. So I'm going to subtract x squared. So I get x squared minus 4x plus 3. And then I'm going to subtract x squared. And I'm going to add 4. Subtract x squared, add 4. Takes care of business. And wouldn't you know it, the x squares cancel each other out. This is actually not too bad. And what is left over is 0 is equal to negative 4x plus 7. So I'm just going to move my work up here. 0 is equal to negative 4x plus 7. I'm going to add 4x to both sides. Then I'm going to divide both sides by 4. X is equal to 7 over 4.